and hello. In this video, we are going to see twisting couple on a cylindrical wire. For this, we should know what you mean by stress. So stress na enna theriyum. Then what you mean by strain. Strain na enna theriyum. Then modulus of elasticity. Modulus of elasticity. So all these three things we have to know. அப்பதான் நம்ம twisting couple on a wire பார்க்க முடியும். So first, I have a spring here attached to a ceiling, right? I have a spring, okay? Let the length of the spring be L. Let the length of the spring be L. Now what I do is, I attach a mass here. I attach a mass here, okay? In the end, I am going to attach a mass. So mass is going to apply a force on the wire in this direction. Therefore, force is given by mass into acceleration due to gravity, m into g. Now the spring is under a force. As a result, the spring has elongated. The spring has elongated by a distance, say x. Length of the spring has increased from L to L plus x. So this is the original length L, and now the spring has elongated to a distance x. Mass or spring adila katti vittodana spring elongate agudhu by a distance x. This elongation is due to the applied force F, which is nothing but this applied mass into acceleration due to gravity. Therefore, F is equal to m into g. Now the stress is the cause na எது இந்த elongation கொடுக்குதோ அது source. So stress is nothing but the force applied per unit area on this spring. That is the force acting on the unit area on this spring. Then strain is given by change in dimension divided by original dimension. Change in dimension divided by original dimension. Okay. So this is the general formula for stress and strain. So change in dimension by original dimension. Stress F by A. F, the unit for F is Newton, and the unit for area is meter square. So Newton per meter square is the unit. Here in meter, here also meter, therefore they get, so no unit for strain, no unit, convenient. Okay. Now modulus of elasticity. ஏன் இது எலாஸ்டிசிட்டின்னு சொல்கிறோம் அப்படின்னு பார்த்தோம்னா, இந்த எம்ஐ எடுத்துட்டேன்னா this spring will move to the original length, right, to the original position. Therefore, when the deforming forces are removed, the object returns to its original position அப்படின்னா the body is called as elastic body, right? So modulus of elasticity is defined as or equal to the ratio between stress and strain. Ratio between stress and strain. Stress divided by strain, we call it as modulus of elasticity. There are three types of modulus of elasticity. First one is Young's modulus. Okay, Young's modulus, which is nothing but linear stress by linear strain. It's the ratio between linear stress by linear strain. Okay. Linear na lengthwise na artham, longitudinal. So linear stress by linear strain. நம்ம இங்க பார்த்தோம், இந்த spring caseல பார்த்தோம். Spring caseல என்ன பார்த்தோம்னா, length alone increases. So force is acting along this direction. Therefore, this you call it as the linear stress and linear strain. என்ன பார்த்தோம் நம்ம இங்க? So this is nothing but force per unit area divided by change in dimension. Length changes. Change in length divided by original length. change in length divided by original length. Therefore, that is Young's modulus is denoted by the letter Y. Therefore, Young's modulus is nothing but F. இது அப்படியே மேலே கொண்டு போனோம்னா அந்த L மேலே கொண்டு போனா FL by XA. Right? FL by XA. That is our the unit. Once again, it will be Newton per meter square, or another name for this is Pascal. Pascal. Newton per meter square or Pascal. Okay. So this is Young's modulus. இப்போ இது நம்ம என்ன பண்றோம், ஒரு சர்ஃபேஸ்ல நான் அப்ளை பண்றேன் ரெண்டாவது டைப் ஆஃப் மாடுலஸ், which I call it as the rigidity modulus. Rigidity modulus. So rigidity modulus, which is denoted by the letter N. So that is given by shearing stress. முதல்ல ஃபார்முலா எழுதிடுவோம், அப்புறம் shearing stress by shearing strain. Okay, shearing strain, which is also written as shearing stress by angle of shear. Angle of shear. We are going to see how. Shearing stress by angle of shear. Okay. Now for this I consider a cube, a box like this. Say the length of the box BL. Okay. Now I apply a force in this direction on the top surface. Top la mattum force apply pandren. Bottom is fixed. Bottom is fixed. So this bottom surface is fixed. Top surface alone I apply a force, right? Now what I do is, if I apply the force in this fashion, then my cube changes like this, right? My cube changes like this. The new position, okay? My cube changes to the new position like this. Okay, initially it was in this position, now it has changed. Let this angle be phi. This angle we call it as the angle of shear. So we know that this length is L and this distance it has moved because of this force F is D. Now we can write it as tan theta or tan phi is approximately equal to phi. If phi is very small, then that can be given by, we know the formula for tan phi, opposite by adjacent side. Here the opposite side is D and the adjacent side is L. Therefore D by L, phi is equal to D by L. Therefore this modulus, rigidity modulus, can be written as F by A divided by D by L. That is nothing but FL by AD. Once again, right? Here also the unit is Pascal. So another type of modulus is, third type of modulus, we call it as the bulk modulus. Bulk modulus. We call it as the bulk modulus. Okay. What is the formula for bulk modulus? Bulk modulus is usually represented by the letter K. Therefore, K is equal to volume stress by volume strain. Volume stress by volume strain. Volume strain. Right? Suppose I have a cube like this. Okay, இப்போ ஒரு cube எடுத்துக்கிறோம். இந்த cubeல I apply force on all the directions. I apply equal force on all directions in this direction, right? So front, back, நாலு side, எல்லா sideலையும் I apply equal force. F, etc. Then the volume shrinks. So there is a change in the volume. Volume மாறுது. Therefore, this type of modulus we call it as the bulk modulus, which is once again given by the formula F by A divided by change in volume by original volume. Change in the dimension. Okay. So this is F by A can be written as pressure. pressure is F by A, and if you take this V over here, then PV by small v. So this is the formula for bulk modulus. For calculating the twisting couple on a wire, we are going to concentrate only on the rigidity modulus of the wire, right? So we are going to concentrate on the rigidity modulus of the wire. That is the reason we have discussed the modulus of elasticity here. We see the twisting couple of a wire on our next video. Thank you.